Hey guys, today we'll be solving LeetCode number 78, subsets. This is a medium problem on LeetCode. Now, I'll just get started with a very brief introduction of what sets is, because I'm assuming you've learned a little bit about sets and you know what a subset is at least. For those who don't know, if you're given 1 to 3 essentially, right, you have to consider a subset as one of the subsets in a subset is an empty set. Then you do choices like 1, do 2, do 3, 1, 2, and so on. You're essentially considering all possible combinations, right? And you have to keep in mind that the empty set is also a possible answer in this case, right? So if we wrote out the branches that we would take, right, because this is a recursion based question, right? This is a backtracking recursion based question. So let's consider the paths that we will take. I'll draw out one very brief one. So let's say we don't pick anything, we don't pick anything, and we don't pick anything. For all three choices, we don't pick anything. This gives us our empty set, right? Now let's consider the idea that we didn't pick anything on the first one. Then we picked 2. Then we picked 3. 2, 3 like this. And we did not pick anything, so we were left with 2. This would account for 2 over here. This would account for 3 over here, right? This path. There's also a path where we only took 1 instead, and this went to 1 only, or it went to 1, 2, 3, so on, right? So there's a lot of different combinations that you can take, right? And at the end you would also need a 1, 2, 3. The array itself is also a subset, so there's a lot of combinations you can take, right? And this points to recursion questions, and in particular backtracking approaches, right? Because you do make a choice and then you go back, and then you make another choice, and then you go back, you make another choice, you go back, right? And etc and etc. So you keep doing these things. So what do we essentially want to program for? There's only two things that we want to program for, right? It is we don't take or we do take. So take, don't take, and then you just have to believe in recursion for it to get the job done for you, right? So what do we have to program? Take and don't take, right? So let's figure out how we could code this up. So if we have some result, right, and we have some temporary array storing our current subset, let's also write down an n to make things easier, and let's call our helper function inside. Okay, so this is our very basic setup. It's the same one as I used in permutations, right? If I is equals to n, then whatever our array is, our subset array is so far, store that into a possible answer. Okay, now how do we not take anything? So temp is storing our current result, right, our current subarray. So how do we not take anything? Well, we just don't take anything by just sending the function over again without doing any sort of processing. We just do dfs I plus 1. So if you can imagine it, then it's literally just doing we didn't pick anything, we didn't pick anything, we didn't pick anything. At the end it will add this to res, right? And so now we will have our empty subset in the answer, right? Or we could have picked something. I haven't written down the picking something logic just yet, but we could have picked something and it didn't pick anything, right? 1, 1, and we got our 1 as our subset, right? But now how do we pick something? Well, to pick something, it's also pretty simple, because we don't really so the ordering will remain the same, right? This is not like permutations where the 3 to 1 and 1 to 3 account for different rotations. Now 1, 2 and 2, 1 account for the same thing, right? That's why you don't see it repeated twice in the answer. 1, 2 and 2, 1 mean the same thing. So since we don't really care about ordering, we can blindly take the index that we are at, right? So if we're sitting at, let's say we picked 1, okay, now we are at index 1, right? So 0, 1 2. Let's write this out. So 1 2 3. Let's say we picked at index 0 1 over here, we've added it. Then our next iteration, it will send this, right? Obviously it will send the empty subset and whatever. The next iteration, it will also add 2, because 2 is at the next index. It won't collide with 1. We don't really care about the ordering. Nor will it pick 3 before 2, right? I mean, it could after it takes the path, but in a sequential order we wouldn't see that happen in our brains. But the recursion fairy would also come up with the part where it would see 1 and 3 and it would do it. But for the sake of logic and explanation, you can think of it like sequentially 1 2 then 3. It will pick it like that. So once we do have picked it, we'll send another recursion fairy to do it, and once we have picked it, we'll pop it off. Right, so we could also think of another situation where it would be pick 1, then pick 2, pop 2, pick 3, and then 1 3 would come out. Then would do 0, so let's say 1, then pop 1, do 2, do 3, so we've got 2 3 right after. Right? So you just have to believe that recursion essentially comes up with the complete answer for you, and at the end just return your results. So what we have done, don't take and take over here, pop from take, right? So key stages over here, and that's pretty much it for this question.